Okay, we could label this section as specifically special parallelograms, because these three shapes are parallelograms. So the very first thing that you'll see in their definition is it's going to say a parallelogram that. Okay? So because we're going to say that it's a parallelogram, it has all of those parallelogram properties, okay, which we're going to write down in just a minute. So first definition is for a rhombus. A rhombus is a parallelogram with 4 congruent sides. So you might think, wait a minute, isn't that a square? Right? So a square is a type of of rhombus, that is true, but not every rhombus has to be a square. A square is a very special type. So if you ever watched cartoons as a kid or ever listened to Fisher-Price, right, you would have heard that the shape that looks like this, okay, so that's a terrible drawing. A shape that kind of looks like that, Fisher-Price calls it a diamond. It's not a diamond. There's no such thing as a diamond in math. This is a rhombus. So a rhombus is that diamond shape, quote unquote. It's not a diamond, it's a rhombus that has 4 congruent sides. It's also the shape, if you watched the Super Bowl last year, it had tons of Orkin commercials where that creepy bug like came to the house and like knocked on the door. If you ever saw those commercials, the Orkin symbol is also kind of that diamond shape. It's not a diamond, it's a rhombus. Okay? Okay, then a special type of that would be a square, which we're going to get to in just a second. So 4 congruent sides. The rectangle, this is the one we're comfortable with. The rectangle is a parallelogram. With 4 right angles. Okay, obviously we can draw ourselves a little picture of that. If I was going to see if something was a rectangle, would you have to tell me that all 4 of them were 90? Well, no, because if you showed me 3 90 degrees, I would be able to figure out on my own that the 4th was also 90. Okay? So yes, it does have 4, but you only have to see 3 of them to say, oh, yep, that thing's a rectangle. Because then the 4th one will just come. Okay? Which means, okay, so this means if all of the sides are the same, that has a special name. Having all sides the same is equilateral. That's the fancy name for having all sides the same. Equilateral. Then what's the fancy word for having all the angles the same? Equiangular. Yeah, that's the fancy word for all angles the same. And then we have our square. So if you're comfortable with or familiar with Venn diagrams, a Venn diagram for these special parallelograms would kind of set up like this, where you have your world of rectangles, maybe over here. You have your world of rhombuses here, and right smack dab in the middle would be your squares. So squares not only have 4 congruent sides, but they also have 4 congruent angles, right? So everything that's true about a rectangle and everything that's true about a rhombus is true for a square. So a square is a parallelogram. That is both equilateral and equiangular. And there's a fancy word for saying that. If it is both equilateral and equiangular, there's another word for that. So I'll put a picture here. We know pretty much what a square looks like, but if we mark it, so we've got our 90s. The fancy word for all the sides and all the angles being the same is regular. Okay, and those are all words that we've heard before. We just have to know that we can apply those things to these shapes. Okay? Okay. Whoops. Now we're going to break this down, one shape at a time. So first shape we're going to talk about is the rhombus because you're not familiar with it, and then we'll finish with a little bit easier one, the rectangle. Okay, so the first one we'll break down is the rhombus, but before we do that, because this is a parallelogram, that means all of the parallelogram properties apply. What are those properties? We're going to write them down. Okay, what's up? Any property of a parallelogram. Go. Go ahead.
That two sets of sides are parallel.
Two sets of sides are parallel. And more specifically, it's the opposite ones. Okay, so we're going to say opposite sides are parallel. Now, that's not technically a property. It's the definition, but we're writing them all together. So that's technically the definition, but that doesn't matter. What else? Opposite angles are congruent. Go ahead. Diagonals bisect each other. And I know it gets kind of long, but it is kind of important that you put diagonals bisect each other, because all of these properties that we're writing down right now, if it's not opposite sides with an S, and if it's just one pair of opposite sides, it becomes a different shape. So here, this is two pairs of opposite sides parallel. If it's only one, that's going to be a different shape that we're going to talk about on Friday. If there is only one pair of opposite angles congruent, it's a different shape that we're going to talk about on Friday. If only one of the diagonals is a bisector, that's a different shape that we'll talk about on Friday. So all these have to be, that's why the S's are really important. The diagonals bisect each other. Both of them are being bisected, because if that doesn't happen, like I said, it's a different shape. Okay, what else? Go ahead.
Adds up to 360.
It does add up to 360. Let's cut that in half, though.
Two sides add up to 180.
The two angles that are consecutive, the ones that are next to each other, add up to 180. That one's going to be important here for the rhombus, because that's true for a rhombus, but you're going to forget that that's a thing when you go to do your actual rhombus homework. Okay, so this one right here, the consecutive angles are supplementary. And then we've kind of been jumping around, so this is kind of a simple one that we've kind of forgot. The opposite sides are equal. So the opposite sides are equal to each other, or are congruent. Okay? Okay, and then here's the last one. This is not a property. It is a property, but this right here particular is, if you're looking at a shape, what is the minimum you would need to know to say that it's a parallelogram? So this is, if you look at a shape and this happens to be true, you can say that it's a parallelogram, and we just want to keep this one in the back of our mind for when, by the end of the week, we have 7 new shapes, and you have to look at the shape and tell me what shape it is. Okay? So there's a total of 8 shapes, 7 new ones just this week. You have to look at the shape and say, that shape I know for sure is a blank. And this one is for a parallelogram. So we have one pair of sides, both parallel and congruent. So hopefully that's not completely different, completely new. That's something that you've heard of before. But it's definitely something that by the end of the week we're going to be using. Okay? Okay, so let's talk specifically about the rhombus. All right, number 1 for the rhombus is its definition. I understand it says properties, but we're going to put them all together so you have an idea. So the first one is you've got 4 congruent sides, right? 4 congruent sides. So because I wrote that down, I'm going to put those markings on my first picture here. I'm going to go ahead and put tick marks on the 4 sides. So other than its definition, what we're really going to be focusing on and honing in on is the fact that the diagonals of all of these shapes that we're talking about are special in some sort of way. Okay? So the definition is going to tell us something about the shape. It's going to tell us something about the sides. But all of the properties that we're going to deal with the diagonals. Okay? So in order to find my first property, I need a diagonal. So let's draw one in. So I'm going to go ahead and draw this diagonal in. Okay, so I have 2 triangles. Would you be okay if I said those 2 triangles are congruent to each other? Okay, couple of ways to know for sure, because you're like, some of you are like, no, where did you get that from? Well, first of all, I could mark reflexive, right? I could mark that line I just drew in there as reflexive. Let me go ahead and mark it. And those 2 triangles would be congruent by side, 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 right? But I could also, not even looking at reflexive, I could also mark the opposite angles congruent, because we just said that. Opposite angles are congruent. So I could mark this angle congruent to this one. Okay, so it could have been side, 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 or could have been side, angle, side. Doesn't matter which one you would have gone with. Okay, and I'm not going to ask you to do proofs. I'm not asking you to do any proving. Okay, I just need you to understand where these properties are coming from, and I'm not just pulling them out of the air. Like, this seems like a good one. Pluck. And I write it down. Okay, it comes from somewhere. So these 2 triangles are congruent, which means now I can say whatever I want. I can say anything I want that's left over. So what I want to say is I want to say something about this guy right here. It's the only thing not marked, right, is the angles. Okay? Which angle do you think that one is congruent to? Okay? Do you want the upper or lower? Lower triangle, okay. And on the lower triangle, do you want the right one or the left one? The right one? Okay. Okay. Now, I could have told you that before we even started. Because it's a parallelogram, right? And these would be alternate interior. Okay? Let's go a step further. When I marked this as a rhombus, it became isosceles, right? And if this is an isosceles triangle, isn't this angle congruent to this angle? So actually, when I asked you, what do you want? Do you want top or bottom? There was no wrong answer. When I asked you, do you want right or left? There was no wrong answer. Because all 4 of these angles are equal to each other. And that gives us our first property. You may not know what the words are for that first property, but that's the picture. Let me just put some numbers on it so that we can feel a little bit more comfortable about what just happened. So let's say this is 20 degrees, and this is 20 degrees, and this is 20 degrees, and this is 20 degrees. All 4 of those angles would be the same number. Okay? Then what would this one and this one be? 140. Because it would be 180 minus 20 minus 20, which would be 140. So these two would both be the same as well. Okay. So there just gives you a picture. Sometimes when we have numbers there, it makes it a little bit easier to grasp what's actually going on. Okay. So what just happened? What just happened is this diagonal right here cut this into equal parts. How many equal parts? 2. What is the fancy word for cutting into 2 equal parts? Bisect. So here, our first property of the rhombus is that the diagonals bisect the angles. Okay, so all of those angles right there are going to be equal to each other. Yes?
So it's an angle bisector, and because of that, we can use. Wait, never mind. No, I thought
we're gonna keep going with this idea. So hang on and see if I answer your question. Okay. Okay. So let's move this forward. Okay. So now on this picture down here, to get our next property, I'm going to draw in both diagonals. Okay. There's one. There's two. Do you see how this is going to become a little bit overwhelming? Because so far, we have only learned 2 properties of one shape. And today alone, we're going to talk about 3 shapes. And then on Friday, we're going to talk about 3 more shapes. You see how this can get a little overwhelming? So you have to make sure that you are staying on top of your practice, because then the rest of it will come a lot easier. Okay? All right, so I went ahead and drew both diagonals in there. Here's what we know so far. Based on what I just talked about, here's what I know. I know this angle is congruent to this angle, is congruent to this angle, is congruent to this angle. Okay, that's what we just talked about. I also know from the definition, I know this is congruent to this, is congruent to this, is congruent to this. That's what I know so far. Because this thing is a parallelogram, and this is the property that we forget the most, because, again, that's a parallelogram property. That's not a rhombus property. No, all of those apply here. So what I can do is I can also say that this is congruent to this, and those two are congruent. Why? Because in a parallelogram, the diagonals bisect each other, which is why we wrote down these properties, so we could keep pointing back to them saying that is still true for our rhombus. Okay? So now we have this picture here. Do you see that all 4 of these triangles are the same? If you look at the tick marks, there's a 1 tick, 2 tick, and 3 tick on every single one of those triangles. Okay, so what that means, again, they're congruent by side, side, side. Now I can say whatever I want. Which means I can now say also that this angle is congruent to this one, which is congruent to this one, which is congruent to this one. But we already knew that because I just wrote down that the diagonals were angle bisectors. But here's the best one of all. Here's the next property. I haven't put it on there yet. Here's the next property. It happens right here. What is true? Slide this up so you can see it in the back there. What is true about these 4 angles? They're all congruent to each other. And if they're all congruent, and they're all next to each other, they all have to be a very specific number, 90 degrees. Yes. So let's put in those 90s. Okay, what is the fancy word for when 2 things come together at 90 degrees? Begins with a P. There it is, perpendicular. So the second property right here that we're going to write down is that the diagonals are perpendicular, which just means you've got 90s all around in there.
So it basically just adds up to 360.
Which it will,
Like
yes.
you said.
Like you said.
What's the fancy word? 360.
It's a number. It's a fancy number. And it does add up to 360. Okay. So this last one is kind of a trick. This is actually not a property, but I just want you to have it down and I want you to know this. It's something that happens, but it's not technically considered a property, and we already talked about it, but I just wanted to write it down. This creates, when you put both diagonals in, it creates 4 congruent, here's the important part, right triangles. And the one thing that we sometimes forget about is you think that we moved on from Unit 7, so we're done with Unit 7. We moved on, so we're not going to use that again. Unit 7 had 2 very important concepts, Pythagorean theorem and sine, cosine, and tangent. And when can you use those 2 things? You can use them with a right triangle. So when we are doing these problems and when we are dealing with a rhombus, you can use right triangles, allow you to use the Pythagorean theorem and sine, cosine, and tangent. So do not think that just because we finished our last unit that you're never going to see those again, because we're going to see it in just a second when we do our first actual problem here. Okay, so this box right here with all of these properties, I would have this next to you when you're doing every single one of your homework problems because it tells you exactly what is true. All right, we're going to flip the page here and we're going to go to the box on the bottom. It would be box 4, slide 4, if you will. Because we're going to do the number example first, and then we'll get to the non-number example, okay? Okay, so it says the diagonals of a rhombus intersect at V, given that that angle is 34, which it is marked already. So we have a 34-degree angle, and we have that WV is 7. Now, I understand they're asking us stuff, but take a time out. Don't look at what they're asking you. Fill out what you know. Here's what I know. The first thing I know is that if this is 34, so is this one. What else is 34? The other 2 at the top, right? So the 2 at X are also 34s. Go ahead.
Don't you also know what the other angles are?
Yes. How do I know?
Because it would equal 180.
Okay.
180 minus 34. And then you get 146. Right?
So are you saying this angle's 146?
No, I'm saying the whole.
The whole thing is 146?
Yeah.
I get where you're going. I understand that. But we're forgetting one very key fact. And that's what these angles are. 90.
Yeah.
So these are all 90. So now you're right. I can figure it out now, but I'm going to use the 90. Okay? So now to figure out my last angle in the whole problem here, I'm going to do 180 minus 90 minus 34. 56. Okay. Now, any angle they ask me for, I can figure out. What should I do with that 7? The only thing you can do with the 7 is put it here as well. It is not ZV, that's not 7, and XV is not 7, and XY not 7. None of those other ones are 7. Okay? All right, let's see what we got. WZV. WZV. That's this one right here. 34. WY. That's the whole diagonal. So 7 plus 7, 14. XYZ. XYZ. Ooh, that's the whole thing here. X to Y to Z. That's both of these two together. So 56 plus 56 is 112. Okay. Here is one that you can't figure out based on your picture. I can't figure out XY. I'm going to on purpose label it with this letter to maybe trigger your mind as to what we might be doing with it. I'm going to call it H. Why would I call it H? Because it's the hypotenuse. Yeah, all of the sides are actually the hypotenuse because they're all equal to each other. But now you have to pick. Do you want to work with 34 or do you want to work with 56? 34. Okay, so we're going to work with 34. So 34 being right here, you have to use the 7. So is 7 O or A? 7 is opposite, so that's going to be O. Do you remember which one is OH? So sine. So here we go. Sine of 34. And that's going to be 7 over H. Right? Because so is what we said, right? So we do opposite on the top, hypotenuse on the bottom. When I type this into my calculator, am I multiplying or dividing? Dividing. Okay, so I'm going to take 7 times 1 and then divide that by the sine of 34. I think that's 12.5. Is that right? Okay. Thank you. So you get 12.5. Okay. So that just gives you an example of how you might have to use sine, cosine, or tangent, or you might have to use Pythagorean theorem. If we were given xv, we could use Pythagorean theorem, or you could still use sine, cosine, or tangent if you wanted to. You wouldn't have to use Pythagorean theorem. You could use either one. You can use Pythagorean theorem if you're given 2 of the sides. Okay? Let me slide this down, and we'll go back to that top slide. I kind of skipped over that so we could deal with the numbers, which are a little bit more straightforward. Okay, so the answers for this, it says for any rhombus, decide whether the statements are always true or if they're only sometimes true. When would it be a sometimes? Okay, it's going to be a sometimes when it is a special rhombus. Remember that a square is a rhombus. How is that going to help us? Well, just a second, because we're going to look at these properties, and I put some shapes there. When you actually do your homework, there's not going to be a shape for you to write on. You have to draw your own shape. So we'll label this as J, I'm using this right here, JKLM. So you have to draw a picture when you're doing it. So in a rhombus, is it always true or just sometimes true that L is congruent to M? Okay, so we just wrote down the properties on the other side of this, right? The other side of the paper. Did we write down anywhere that consecutive angles were equal to each other? No, we did not. So when would that be true? Well, in a square, which also happens to be a rhombus, isn't it true that consecutive angles are equal to each other? Yeah. Yes. So this one is only sometimes, and it does say explain your reasoning. Sometimes in a square. And that's a comma, not sometimes in a square. It's always in a square, but it is sometimes for a rhombus. And when does that happen? It happens in a square. Okay, let's look at the picture again. We can use this one over here if we need to. Is JK, always or sometimes, that's this one, JK, congruent to KL? In a rhombus, are the sides next to each other, always or sometimes, congruent to each other? So the sides next to each other in a rhombus. What's the definition of a rhombus again? 4 congruent sides. So are the sides next to each other congruent? Always. That's the definition. Okay, so I put my explanation there is that the definition is 4 congruent sides. So the sides next to each other will always be congruent. Okay, let's use a different picture here. KLM. Did we write down anywhere on the previous page that JL, that's a diagonal, did we write down that the diagonals, JL and KM, are equal to each other? Did we write that down? No. So is that going to be an always? No. That's a sometimes. And you'll see why in just a second. So that's going to be in a square. So in a square, you're going to see the diagonals equal to each other. And I'll show you that in just a second. Okay? Okay, that is your rhombus properties and your rhombus information. Take a deep breath. That's a lot of information thrown at you. Right? Now let's do the next one. Yes. No, right now. Because the next one, here's the deal. The next one is a rectangle. Pretty sure you're comfortable with a rectangle. Okay, and there's really only one property of a rectangle that you need to know. Okay, so we'll write in the definition here. The definition of a rectangle is that it has 4 right angles. So 4 right angles is your one thing. That's the thing you already know. That's the definition, and we should already know that one. So what's new? The new part about a rectangle has to do with its diagonals. So again, everything we're talking about today is diagonals, diagonals, diagonals. So what is true about its diagonals? Diagonals, okay, and they're not going to be perpendicular. Let me draw them in, and you can see that they are not perpendicular. So there's one of them. Here's the other one. Do they look like they make 90 degrees at their center? No, they certainly do not. So they are not perpendicular. However, if we took a ruler to them, the one thing we would see is that the length here and the length here are the same. So their lengths are equal, or the diagonals are congruent to each other. So let's say, really quick, let's say that the diagonals are both 20, right? So this is 20, this is 20. But because they're parallelograms, they bisect each other. So doesn't that make this 10? And this 10? And this 10? And this 10? Now, that doesn't make 4 congruent triangles like we had in the rhombus, but it does make 2 pairs of congruent triangles. It makes congruent triangles here and congruent triangles here. Yeah, go ahead.
So we could do alternate interior in this, right?
Mm-hmm.
And we could also do vertical.
Mm-hmm.
Okay. Because the sides are
Parallel still, yep. Yep, so all of those things that we were doing before still apply. So I'm going to throw numbers onto this rectangle real fast so you can kind of see what's going on. We have two pairs of congruent triangles, and, spoiler alert, those triangles are isosceles. Right, because we have 10 and 10, which means they're the same. So I'm going to mark them as isosceles. Okay, and I'm going to put a number out here. I'm going to put a 20 degrees right here. Okay, what else is 20 degrees? Well, you just asked, can I use alternate interior? Yeah. So I can put 20 here, right? But they're also isosceles. So where else is 20? Here. And up here. So do you see the two pairs of congruent triangles? Okay. So if this is 20 and this is 20, we already did these numbers before, so 20 and 20, this would be 140. This would be 140. And here's where we forget ourselves sometimes. We forget the things we already know. Okay, we're going to see if you can remember it. What is this degree measure? Right here. Yes. 70. Why is it 70? Because this is 90 degrees. It's a rectangle. You know that, and you know a rectangle has 90 degrees. We just sometimes forget that that's what we're doing. So if this is 90 degrees, we're going to take 90 minus 20. So this is 70, which means this is 70, which means this is 70, which means this is 70. So you've got all four of those being 70. And then you can do 180 minus 70, or you could just do a linear pair right here as well. So this would be 40, and this would be 40. Okay, so that gives you just an example with numbers to kind of show you where the congruent triangles are and how they kind of break down, and to show you how the isosceles part comes into play. Okay, last little bit here, we're just going to answer these questions. On the bottom it says, for the rectangle to decide if they're always or sometimes true. We just did this with the rhombus, so it's the same idea. We have JKLM, so JKLM. In a rectangle, is J always or sometimes congruent to K? Always, because they're all 90, right? So that is always. Okay, your explanation could be whatever you want. It's equiangular. All of them are 90. Definition of a rectangle. Whatever you want your explanation to be. What about JK congruent to KL? Is JK always or sometimes congruent to KL? Sometimes. That's not a rectangle, right? That's a rectangle doesn't have the ones next to each other congruent, but if that rectangle happened to be a square, that would be true. So this is sometimes. Okay? Only in a square. So this is another way you could say it. Only in a square. You wouldn't need a comma that time. Square. Only in a square. Okay, and we just talked about this one. This is the diagonals here. So in a rectangle, is this 90 degrees?
No.
Question mark. Is that going to be 90 degrees? No, not always. Sometimes, when that happens to be a square, okay, so like I said, it's super important that you practice at least some of the problems tonight. We're going to get another worksheet on this tomorrow. We're going to finish up the notes on rectangles and rhombuses tomorrow, but you can still do all of the homework. Super important that you practice, because once we start adding on to this, it's going to make it a lot more difficult to remember all of the different properties and to keep those all separate.